Okay, I think that's good. Good. Yeah. Hello, and welcome to another video. Today I'm with Lincoln again. We're going to be running through another mock interview. So, yeah, Lincoln's going to be choosing a problem for me, which I don't really know about, and we're just going to run through it and hopefully simulate what an actual interview would look like. Okay.
Hello, it's
Yeah.
it's ASMR Lincoln because I'm currently in a very quiet facility and I don't want to be too loud.
Yeah.
So, all right, right into the question. So the question is, it's called evaluate reverse Polish notation.
Mm.
And let me go ahead and paste in the text for you.
Okay.
How do you do like multi-line comments in Python? Can you even do
Yeah, you can
that?
do this. I'll go ahead and do that. To convert it to multi-line comment. There we go.
Okay. So let me go ahead and read the question for you. Um, so you're given an array of strings tokens that represents an arithmetic expression in a reverse police notation. So you're going to want to evaluate the expression and return an integer that represents the value of the expression. So there's some notes. The first is the valid operators are plus, minus, multiply, and division. Each operand may be an integer or another expression. The division between two integers always truncates towards zero. There will not be any division by zero. The input represents a valid arithmetic expression in a reverse Polish notation, and the answer and all the intermediate calculations can be represented as 32-bit integer. So I feel like this kind of like the description by itself doesn't really do much for you. So I'm going to go ahead and give you an example.
Okay.
Um, so there's a simple example. So you make an array of strings like that,
Mm-hmm.
and it gets converted into like 2 plus 1, and then you get the result of that, and then you do like times 3 on that, and you end up with 9.
Okay. 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 Yeah, that makes sense. Mm, okay. I'll go ahead and maybe start off with another example just to better understand it. Or okay, so we have let's say like five like 4 1 minus 3 and then like yeah, just like I guess I can keep it as multiply. So um so reverse Polish notation is okay. So okay, I see. So for this one, you get 4 and 1, and you do a subtraction symbol, meaning you subtract these two to get the final answer 3, whereupon you multiply 3 with, like 3 with the result of this, which is 3, equaling 9, like the same output as the previous one. Um, like basically like in that order, right? So,
Mm.
okay, I see. Hmm. Okay, so I'll take a look at the notes here. So these are the valid operations. Okay. Um, like you said, integer or other expression always truncates towards zero, and you can't divide. Okay, yeah, no division by zero, and yeah, okay, representation as an integer. Okay, this makes sense. Okay, so hmm. Okay, so just taking a look at this problem, one way I'm thinking of doing this is by using a stack. So my current idea is we have a stack that pretty much like let's say like we have a stack here, right? We have a stack that as you traverse through every single element in the tokens array, we add that element to the stack. So we have let's say like 2, 1, and then like basically add any integer. For items which aren't an integer plus, we want to pop the previous two items in the stack. So we can do stack.pop twice. Let's say like for adding, pop stack twice, and then what we can do is append to the array the result, or like append to the stack, stack the result. The reason why I'm appending it to the stack is because I'm noticing for 4 and 1 here, we subtract the 2 and we get 3 as the final result. And that's what we want to use for the arithmetic expression here. if we add it to the stack, then we can have that output and multiply it with another operation that we can do like later on, like for example like the multiplication thing. So yeah, basically add integers to the stack, pop the stack twice if you're doing like an expression like a adding and multiplication. So maybe for adding and subtracting, pop stack twice, add to the stack the results, and for well actually yeah, adding and multiplying. And then for situations where you have to divide or subtract, the order of operations matters. So the nature of a stack popping is that when you pop it, it takes in like the very top elements, and in that case, that's not what we really want, right? Because we want to get 4 first. So we also have to keep that in mind when we're implementing the stack. So we'll have to account for that. But yeah, but basically the general gist of the idea is that I add integers to the stack, and when I have an operation, I pop elements in the stack, perform it, and add that element to the stack, and then at the very end, I return like the remaining value in the stack afterward as that final result. And yeah, so also to account for the two integers always truncating towards 0, if I remember correctly, Java and C++ automatically handles this, but in Python, in order to have the two integers truncate towards 0, what we would have to do is we would have to convert it into a float first, like float like the um, number 1, and then like perform an operation on number 2 before surrounding that in an integer, like an integer converter, in order to like have it successfully truncate towards 0. But yeah, those are basically just some things I'm gonna watch out for as I complete my implementation. But does my general logic sound valid to you?
That's actually fucked up, bro. You sliced through this medium like it was a hello world exercise.
Yeah, sorry. But is,
Anyways, yeah, that's right, that's right. About the order of operations though, like I'm pretty sure like Polish notation just like it's just evaluate as it comes. Like you don't need to worry about order of operations.
oh, okay, I
Yeah.
see. I'll keep that in mind when I begin implementing my solution. But
Mhm.
okay, so is it fine if I begin or?
Yeah. Go ahead.
Okay. So I'll have like maybe I'll call it reverse Polish, and then looks here we're given an array of strings tokens, right? And then with the token, let's see, return integer that represents the value of it. Okay, so the first thing that we have to do is you create the stack. So we have the stack that with the elements that we're going to populate, and then we'll begin iterating through the tokens. So for v in tokens, the first thing we want to do is check to see whether or not all of these operations like are probable. So we'll have, let's say like if v equals plus, and then we want to perform an action. If v equals plus, then what we want to do is we want to pop those two elements from the stack. So stack.pop, and then stack.pop again, stack.pop again. And then actually what we need to do is we need to add both of those values and append that to the stack. So append that to the stack again like this. So stack.appends. Okay, so otherwise, if it's a integer, well, what we're gonna want to do is just add that integer value to the stack. So stack.appends value. Okay, now we need to also handle the other cases as well, where you have, let's say like multiplying, dividing, subtraction. So we'll go ahead and change those values over here. Okay, so for this, for multiplication, we can modify this and make this instead. For dividing, we want to pop from the stack, but we want the topmost elements. We want the topmost element to occur like let's say we can have like we pop like 2 and 1 from the stack. If we want to do like 2 minus 1, uh, and this is the stack. What the stacks look like. Like you have to pop it out so the 2 appears first. So we have to do like we can say like let's say like a b equals stack dot pop and then we can do b divided by a, and then we append those values to the stack. For subtraction, the the order also matters as well. So we're gonna want to go ahead and do a subtraction thing over here, and then at the very end, after we perform all of these operations, we're gonna want to return the the very top element in the stack, because at the very end what should happen is that the final value will be 9, because let's say for like this example we have 2 and 1 that's equal to 3. We encounter this, we pop those two elements in the stack, becomes 3. 3 and 3, those are valid. We append this to the stack and we hit this arithmetic symbol. We multiply those two symbols again, together in order to compute 9. And then from there, from 9, what we do is, since that's the last element in the stack, there's nothing else, we can return that value at the very end. So yeah, so the time complexity of this one would be O of n, because you're only traversing through the array once, and the space complexity of this would be also O of n, because in the worst case, you would be populating the entire stack with numbers before, let's say hitting an arithmetic symbol. But yeah, yeah. Do you have any questions?
Nope. Is that the end of your solution?
Yeah, let me just check again. Stack, value tokens. Oh, actually, another thing we need to look out for is we need to make this LF statements, so it's all just like one conjoined thing. Yeah, because reason being, if we just made them all if statements, then like anything other than the subtraction statement would append to the stack, which is not what we want. So yeah, I think this is the end of my statement. Yeah, end of my solution.
Okay. Yeah. That's actually fucked up, Matt. I'm pretty sure this is right. Like you just have minor syntax errors.
Oh,
Do you want to try
okay, I'll take a look. Oh my god. Oh, I'm stupid. Okay. I'll go ahead and take a look again. Plus for value and tokens, you want to check if it's plus subtraction. This. Stack.pop. Stack.pop over here. The stack.append b minus a. Yeah. Okay. I think those should be the only syntax errors I see.
Or do you want to try running this?
Okay.
Let me try running this real quick.
Okay. Wait. Sorry. Wait. Actually, I just noticed something.
Yeah.
Like I was saying earlier, I actually need to truncate towards 0. So what I need to do is for the division operation, I actually need to, instead of doing b divided by a, I have to do let's say like int float b divided by a, like this, and then yeah, maybe you might have to copy that again.
I suspect it might be you actually might not need to do that.
I think it depends on the version of Python that you're using. If it's like Python 2, it should be okay. But for Python 3, this is how.
Oh, are you serious? Damn, bro.
You might wanna, I could be wrong though. So maybe run it through the compiler and see.
Oh, okay. Actually, do you want to go ahead and do you want to go ahead and try casting to int, because they're actually strings.
Oh, I see.
when
I see.
when you append numbers, yeah.
Yeah.
You should cast.
Yeah.
Okay. Let me try this out then, and let me let me go ahead and just rename this to eval reverse pulse notation, because that's what it's called in LeetCode.
Oh, okay.
Yeah. Let's see. Damn, copy pasting just completely fucked up this.
Yeah, I think it's a tab spacing. Yeah.
Yeah. see. Holy fuck, bro! It worked.
It worked. Yeah.
Yeah,
Yo. Okay. Do you want to know a
that's
secret?
actually what.
I've done this problem before.
That's fucked up, bro. That's
Yeah.
that's racist.
Yeah.
Okay, so this is yeah, that was perfect. The honestly, there's like I have like such minor criticisms, man. I like the yeah like the structure of the interview was perfect.
Hmm.
You like went through an example. You like gave out a you like explained a high level. You asked for confirmation,
Hmm.
and then you went in and like coded up while you were talking. Um, so that was perfect. I think if I really had to pick something, it would be uh, I, I think it'd be cool if the example that you wrote wasn't just a comment, but it was an actual assert statement that you could run. Um,
Oh, right, right. So
yeah,
like here wait, no. Like this one, right?
yeah.
So like I guess like in the format for like an actual interview, it'd be assert assert true like this like inputs and then like output, right? And then like that, right?
Yeah, actually, in Python, the assert statement is assert and then eval reverse post notation. You paste in that array. Whoops, this one.
Is that a built-in function like assert?
It is, yeah, it is.
Oh.
And then you can do like that.
Oh, okay, okay, I see.
Yeah, and then I would also recommend like making out a simpler example, like one more simple example. So the example that I would have wanted to see is like um eval for false notation, and then I probably would have wanted to see something like very simple, like 2, 3, and then just like
Oh, it's
plus
like a
like
plus.
that.
Oh, okay, okay, I see. Yeah.
Yeah, and the reason why is because by doing this, it makes it very explicit that the whatever operator it is operates on the two previous elements.
Mm-hmm.
Yeah, because and I think that was a key point of the topic. I mean,
Okay.
like it, like you obviously knew it, but it would have been a good idea to like make it explicit to the interviewer as well.
Right. That makes sense. Yeah. Yeah.
Yeah.
Okay. You know what? I'll do this for all my future ones. Actually, this is the pretty smart. And then
Mhm. Um,
also yeah, I also noticed you caught a lot of syntax errors, so I gotta fix that. Yeah.
yeah, yeah. I don't think it's like that deep though. I think it's all right.
Mm,
Yeah, that's
yeah.
hype, man. That's
Okay.
that was really good.
Oh, thanks. Yeah, I've been practicing while you're like doing the like stuff. So, yeah.
Hmm.
Oh, okay. I can yeah, I'll run through a problem with you now then.
Yeah, for sure.
Okay.